This video is going to review for you properties of exponents. So the first one we want to look at is products of powers. If you have x squared times x to the fifth, really what that means is we're multiplying x to itself 2 times. So x times x. And x to the fifth means x is being multiplied to itself 5 times. So this right here is a multiplication, x squared times x to the fifth. So we're multiplying the two together. In total, we have 7 factors of x. We have x to the 7th power. Now the shortcut rule for that would be if you have two bases that are the same, you can add the exponents. So multiplying powers with the same base, you add the exponents. And we have an explanation or a formula here, a to the m times a to the n. So you have the same base, different exponents. They could be the same exponent, but same base. You keep the same base and add the exponents. So let's go ahead and try one. If we have y to the fifth, y to the fourth, I can imagine I have 5 factors of y and 4 factors of y. In total, I have 9 factors of y, or just 5 plus 4. Here, I'm going to keep my same base. Y was my base, y was my base, y stayed the base. 2, 2. My base stays the same. I have 4 factors of 2 and 2 factors of 2. In total, I have 6 factors of 2. 2 to the 6th. And here, same base, 3, 3. So I can use this rule, keep the same base. Now I need to add 1/2 and 5/2. When adding fractions, the denominator needs to be the same. It is the same. We're adding the same size piece. This is a half a pizza, and this is 5 halves of pizza. So how many total halves do we have? We have 6 halves, which really is just 3. So it would be 3 to the 3rd power, or 27. 2 to the 6th power, let's see, what is 2 to the 6th power? If you have something like 2 to the 6th power, you want to go ahead and multiply it out. So 2 times 2 is 4, 2 times 2 is 4, 2 times 2 is 4. 4 times 4 times 4 is 64. All right, now I have an artistic representation of the same exact property. It's two things, two powers with the same base. You keep the same base, you add the exponents, and that shows an addition of the red and the yellow. So it's just the artistic representation of that property. This is one very important property you need to know. All right, another one is power of a power. So notice this is different. This is not saying x to the 7th times x squared. It's saying x to the 7th, that quantity, squared. So really I could rewrite it as x to the 7th times itself, because it's saying 2 times. So now I can use the rule from before. I can add my exponents and I get x to the 14th. But in case I don't want to do this middle step, to get to 14, I could just multiply 7 times 2. So the rule for this is if you have, let's read it. When you have the power of a power, you multiply the exponents. So here we have a power to another power. So power of a power, you multiply the exponents. So base to some power to another power, you multiply the exponents to get the new power. Notice the base stays the same. All right, so let's try some. We've got 2 to the 3rd power. Again, I could write it out in 3 factors of 2 to the 3rd if I wanted to, and then add those up. But I'm just going to use my shortcut rule. 3 times 3, I get 2 to the 9th power. And I'd want to multiply that out and see what I get. Here we get x to the 15th. And here we get, same exact rule applies. So I keep my same base, 3, and I multiply the exponents. What is 1/3 of 12? Well, that really is just saying 12 divided by 3. 12 divided by 3 is 4. 3 to the 4th. So 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. All right, so final answer. And here, 2 to the 9th. Well, I already saw that 2 to the 6th is 64. And then times 2 times 2 times 2. So 64 times 2, 128 times 2, double that. Let's see. 240, 50, 256. And times 2 would be 512. So it's 512. And that is power to a power. Again, here is the artistic representation of that. We have a power to another power. You're going to multiply the powers, and here it shows red and yellow are mixed together kind of to give an orange, so that you're multiplying the powers when you have power to a power. All right, I think we have one last thing we want to look at. A power of a product. So here we have 3x, that quantity to the 3rd power. So everything inside there is being cubed. So we could write it out 3x times 3x times 3x, because everything is multiplying to itself 3 times. So you could rewrite it as 3 to the 3rd power and x to the 3rd power. That's a 3, sorry. Okay, so really, it's almost like we're distributing this power. This power applies to the 3 and the x. So 3 cubed is 27, and x cubed stays x cubed. So let's check this out. The rule says, when you take a power of 2 things that are multiplied, you raise each part to the power. So here we have xy, the quantity xy to the 3rd. We're going to give x to the 3rd, y to the 3rd. All right, how about this one? 2 to the 4th, x to the 4th. Now I'd want to multiply that out. 2 to the 4th, 2 times 2 is 4, and 2 times 2 is 4, and 4 times 4 is 16, so we get 16x to the 4th. And here, 8 to the 1/3, x to the 1/3. Now, this we haven't learned yet, but if you plugged in your calculator for now, 8 to the 1/3 power, you would see that it's 2. It's saying the cube root of 8. So what times what times what gives you 8? Well, 2. And we'll be talking about that more in the future. But 2x to the 1/3 is what that would end up being. All right, so the rule, we've got a product to a power is the same as that power applying to both bases. Now, we need to note, here's the artistic representation. If we have a product to a power, the power gets applied to each product as a power. Now, notice right here, this is a multiplication. I have a note down here. Note this only works when there's a product. If it were a sum or a difference, you would need to FOIL, right? So let's look at this one as opposed to something like this. How would these two be different? Well, this right here is a product. This is a sum. It could also be minus. But in this case, a lot of students I've seen in the past want to say, oh yeah, it's x cubed plus y cubed, and that is not the case. You cannot distribute that power to this because this is 2 terms. It will not work. So this is 1 term. It's a product. In this case, you would have to multiply out x plus y times x plus y times x plus y. And you would do your distributive property and go x times y, or FOIL or box method, whichever way, and then multiply those all together. Okay, so I just want to make clear that this property of a power going and distributing only works when you have a product, not when you have a sum or a difference. Okay? All right. And I wanted you to create a couple problems. So if you can pause for a second, create a couple problems. You can be creative if you want. I made one here, 2 heart star, that whole quantity to the 4th power. So 2 to the 4th star to the, or heart to the 4th star to the 4th, just to show that that 4 distributes. But I want you to try one of each type. So pause for a second and try one of each type that we just looked at. All right, so I have a couple problems right here. You can attempt these. I have these ones right here. 1, 4, 1, and 4. So try those 4 problems real quickly. Again, I want you to pause it because I'm going to jump to the answers in just a second. So pause. Oh, okay. And I'm sorry. There are the answers. So you can check those 4 problems. See how you did. All right, if you have any questions right now, you want to write them down so that you can bring them to class and we can talk about them. There are also some more. We've got 7, 10, and 13 if you want to try these guys for a little extra practice. That's awesome. All right, I will see you in class.